Okay, so this is our fourth review video for the Chapter 1 review. This video is going to be really short because I decided to do the one solution, no solution, infinitely many solutions video as one. So I'm just going to be working these four problems, and then I'll do our literal equations video as a separate video. So you should be getting close to being finished with your review. You have this section and then your literal equations section, which we're finishing up literal equations this week in class, which is why I decided to wait on that video. So, in exercises 37 through 40, which are these four problems that we have here, we are determining whether the equation has one solution, and that's what we've been doing up to this point on the review. Every equation has had one solution. You wind up with x equals a number. Or if it's going to have no solution, which we'll talk about what that looks like in a moment, or if it has infinitely many solutions. Okay, so when you come across these problems, you're going to solve them just like you have been with everything else. It's just your answer is going to look a little bit different. So let's go ahead and look at number 37. So just like with equations that have two variables on the same side of the equal sign, the first thing you have to do is clean up your equation by combining like terms. So if I have y minus y, those y's are going to actually wind up canceling out because y minus y is 0 y's. So now I'm left with 3 equals 9. So the question is, does 3 equal 9? And the answer to that is no, 3 is not equal to 9. If your variables cancel out and what you're left with is not true, then you know that the answer is no solution to that equation. So for this one, there is no solution because there's no variables left and what we're left with is not true. Okay, let's look at number 38. So for number 38, notice I have variables on both sides here, so I know I'm going to start with inverse operations. The opposite of positive 7x would be to subtract 7x. And when I do that, those 7x's cancel, and I'm left with x on the left. And the opposite of negative 4 is positive 4, so I add 4 to both sides. And we can already see that we're going to have an actual answer here. We have that x is equal to 3. So remember, up here, they're asking me to determine if there's one solution, no solution, or infinite solutions. So for number 38, if x equals 3, that means this problem would have one solution. And that's what you would need to tell me, because they're not asking for the solution, they're asking for how many of them there are. Okay, let's look at 39. So for 39, notice we have distribution on both sides here. So I'm going to start by distributing the 2. So when I do that, 2 times 3t is 6t. 2 times 3 is positive 6. Then I need to distribute a 3 on the other side. Well, 3 times 2t is 6t, and 3 times 2 is 6. Okay, so at this point, most of you will notice that 6t plus 6 is the same thing as 6t plus 6. If they're the same on both sides of the equation, you know you're going to have infinite solutions. But just in case you don't notice at this point, let's go ahead and keep solving and see what happens. When I go to move my 6t to the other side by subtracting minus 6t and minus 6t, I wind up with both of those canceling out. And I'm left with 6 equals 6. So unlike with 37, when my variables canceled out here, what I was left with was actually true. And that's how I know that there's an infinite number of solutions here. So that would be my answer on this one. Okay, I'm going to pause. I've done one of each type. I would like for you guys to try to work number 40, and then you can restart the video and check your work with mine. Alright, so for this last one, this was a great review over solving equations because it had the distributing on both sides, but we had this fraction, and I know you guys are still a little iffy on the fractions. So let's review the distribution part. So I distributed 3 times 5 is 15, 3 times a is 3a, equals, and then I did 1/4 times 28. So I did 1 times 28, which is 28, divided by 4, which is 7. And then 1/4 times 12a, 1 times 12 is 12, divided by 4 is 3a. Then from there, if I'm trying to move all my variables to one side, the opposite of a positive 3a is a minus 3a, but when I subtract 3a from both sides, my variables cancel out. I'm left with 15 equals 7, which is not true, and that's how I knew this had no solution. Alright, so I'm going to go ahead and end this video here, and then I will make a separate video for solving literal equations. You guys have a fantastic evening.